Welcome to the world of Kotlin, a modern, statically typed programming language developed by JetBrains. Kotlin runs seamlessly on the Java virtual machine and is fully interoperable with Java, making it a top choice for Android app development. Google has officially recognized Kotlin as the preferred language for Android, thanks to its concise syntax and robust features. In this module, we'll explore what makes Kotlin unique, how it compares to Java, and why developers are rapidly adopting it for modern projects. Get ready to discover a language designed for productivity, safety, and flexibility. Kotlin stands out from Java in several key ways. First, it drastically reduces boilerplate code, meaning you write less and achieve more. Unlike Java, Kotlin doesn't require semicolons or manual getter-setter methods. Null safety is built into Kotlin's type system, helping prevent common runtime crashes. Additionally, Kotlin supports coroutines for lightweight, asynchronous execution, making it easier to handle tasks without relying on heavy system threads. These features make Kotlin a more concise, safer, and efficient language for developers, especially in Android development. Kotlin offers a suite of powerful features that enhance developer productivity. Full interoperability with Java means you can call Java code from Kotlin and vice versa within the same project. Null safety eliminates NullPointerException errors at compile time, making your code more reliable. Type inference allows the compiler to automatically determine data types, reducing the need for explicit declarations. Smart casts simplify type checks, and extension functions let you add new methods to existing classes without rewriting or inheriting them. These features make Kotlin a flexible and robust language for modern development. Kotlin makes you explicitly decide whether a variable is mutable or immutable using two keywords, val and var. The val keyword creates a read-only variable, similar to final in Java, meaning its value cannot be reassigned after initialization. The var keyword creates a mutable variable, allowing its value to be updated later. This clear distinction helps prevent accidental changes and improves code clarity. By enforcing mutability decisions, Kotlin encourages safer and more predictable programming practices. See val and var in action. In Kotlin, you might declare birthYear as a val, making it read-only and preventing reassignment. On the other hand, currentAge can be declared as a var, allowing its value to change as needed. This approach ensures that only variables meant to change are mutable, reducing bugs and making your code easier to understand. By using val and var appropriately, you maintain control over your data and prevent unintended modifications. Kotlin simplifies class creation by removing unnecessary boilerplate. You can declare a class, its properties, and its primary constructor all in a single line. For example, the smartphone class includes brand and price properties directly in the header. Methods like displayDetails can be added inside the class. When creating an instance, you don't need the new keyword. This streamlined syntax makes your code cleaner and easier to maintain, allowing you to focus on functionality rather than structure. Let's look at a practical example. The smartphone class in Kotlin is declared with val brand and var price properties. The displayDetails method prints the brand and price. When you create an instance, such as myPhone, you simply call smartphone with the desired values. This approach eliminates the need for verbose constructors and makes object creation straightforward. Kotlin's concise syntax helps you build classes quickly and efficiently, enhancing your development workflow. Kotlin fields are treated as properties. When you declare a variable inside a class, Kotlin automatically builds a backing field with default getters and setters. For var properties, you get both getter and setter methods, while val properties have only a getter. You can also override these with custom logic. This property system simplifies data management within classes and allows for flexible customization, making your code more robust and maintainable. Consider the account class in Kotlin. It includes a balance property with a default getter and setter, and an isOverdrawn property with a custom getter. The isOverdrawn property checks if the balance is less than 0, providing a simple way to add custom logic to properties. This flexibility allows you to tailor property behavior to your needs, making your classes more expressive and functional. String interpolation in Kotlin lets you insert variables or expressions directly into string templates using the symbol. This eliminates the need for messy string concatenation and makes your code more readable. For example, you can print a welcome message with a user's name or display the result of an expression inside curly braces. String interpolation streamlines output formatting and enhances code clarity, making it easier to generate dynamic messages. See string interpolation in action. In Kotlin, you can print a welcome message using println, welcome back, profile name. You can also include expressions such as println, you have item count +2 pending notifications. This feature makes it easy to create personalized and dynamic messages without complex concatenation, improving both code quality and user experience. Kotlin's null safety system is designed to eliminate runtime null pointer crashes. The language splits its type universe into two categories, non-nullable types and nullable types. By default, variables cannot store a null value unless explicitly declared with a question mark. This approach ensures that null-related errors are caught at compile time, making your code safer and more reliable. Null safety is one of Kotlin's standout features, providing peace of mind for developers. Kotlin non-nullable types are the default, meaning variables cannot be assigned a null value. If you want a variable to hold null, you must declare it as a nullable type using a trailing question mark. For example, useAddress is a non-nullable string, while secondary address is a nullable string. This explicit distinction helps prevent null pointer exceptions and makes your code more predictable and robust. Safe call operator in Kotlin allows you to safely access methods or properties on nullable variables. If the variable is null, the operation returns null instead of throwing a crash. This operator protects your code from runtime errors and makes null handling straightforward. By using, you can write safer, more resilient code that gracefully handles missing values. See the safe call operator in action. If you have a nullable variable like middle name, you can safely access its length using middle name length. If middle name is null, the result is null, and your program continues without crashing. This feature is especially useful when dealing with optional data, ensuring your code remains stable and error-free. Elvis operator in Kotlin provides a convenient way to supply a default value when a nullable expression yields null. It acts like a compact if-else statement for null handling. For example, you can assign a fallback email address if the primary email is null. This operator streamlines null checks and ensures your code always has a valid value, reducing the risk of errors. How the Elvis operator works in practice. If primary email is null, you can assign active email to a default value like no-reply@domain.com using primary email, no-reply@domain.com. This ensures that your program always has a valid email to use, even when the primary value is missing. The Elvis operator makes null handling concise and reliable. Not null assertion operator in Kotlin forces a nullable value to become non-nullable. It tells the compiler, I promise this variable is not null. However, if the variable is actually null at runtime, your program will throw a null pointer exception and crash. Use this operator only when you are absolutely certain the value is not null. It's a powerful tool, but it comes with risks. See the not null assertion operator in action. If you have a nullable variable like useInput, you can force it to be non-nullable with useInput length. If useInput is null, your program will crash with a null pointer exception. This operator should be used sparingly and only when you are certain the value is not null, as it bypasses Kotlin's safety checks. Extension functions in Kotlin allow you to add new methods to existing classes without modifying their source code or using inheritance. This feature lets you extend external classes, including standard SDK classes like string or int. Extension functions make your code more flexible and reusable, enabling you to enhance functionality without altering the original class. Here's an example of an extension function. You can extend the string class with a custom method like append star, which adds a star emoji to the string. By calling status append star, you get completed star as the output. Extension functions let you inject new behavior into existing types, making your code more expressive and modular. Data classes in Kotlin are specialized for holding data models. By using the data keyword, Kotlin automatically generates boilerplate functions like toString, equals, hashcode, and copy. This makes data classes ideal for representing database records or simple data containers. Data classes simplify code and reduce repetitive tasks, allowing you to focus on the logic that matters. Let's look at a data class example. The employee class is defined with id, name, and department properties. When you create an instance, Kotlin automatically provides useful functions like toString and copy. For instance, you can create a shallow copy of an employee with a slight change in the name. Data classes make it easy to manage and manipulate data models efficiently. Kotlin supports default parameters in function signatures, allowing you to define fallback values. Callers don't have to pass these parameters every time, making function calls simpler and more flexible. Default parameters reduce code repetition and make your functions more versatile, adapting to different use cases without extra effort. Named parameters in Kotlin let you explicitly tag arguments by their parameter names when calling functions. This results in highly readable code and allows parameters to be passed out of order. Named parameters enhance clarity and reduce errors, making your function calls more understandable and maintainable. See default and named parameters in action. The build profile function defines default values for role and verification. You can call build profile with just the name or override specific parameters. Named parameters allow you to switch the order safely, such as build profile, verification equals true, name equals Leo. This flexibility makes your functions adaptable and easy to use. Kotlin embraces functional programming by treating functions as first-class citizens. You can store functions in variables, pass them as arguments, or return them from other functions. Kotlin also provides rich built-in collections processing APIs like map, filter, and fold. These tools enable you to write concise, expressive code that processes data efficiently and elegantly. Let's explore functional programming in Kotlin. You can create a list of points and process them using a pipeline of lambda expressions. For example, filter elements greater than 2 and then map them to multiply by 10. The result is a transformed list, demonstrating how Kotlin's functional features make data processing simple and powerful. This approach leads to cleaner, more maintainable code. Kotlin's type system is designed for safety and flexibility. By distinguishing between nullable and non-nullable types, Kotlin prevents common runtime errors. Type inference allows the compiler to automatically determine the type of a variable based on its value, reducing the need for explicit declarations. This system makes your code safer and easier to read, helping you avoid mistakes and write more robust programs. Smart casts in Kotlin automatically cast a variable to a specific type after a type-checking condition is satisfied. This feature simplifies code by eliminating the need for manual casting. Once the compiler knows a variable is of a certain type, you can use it directly without extra syntax. Smart casts make your code cleaner and reduce the risk of casting errors. Extension functions are not limited to custom classes. You can extend standard SDK classes like string or int, adding new methods that enhance their functionality. For example, you might add a method to format strings or perform calculations on integers. This flexibility allows you to tailor existing types to your needs without modifying their source code. One of the advantages of data classes is the ability to create shallow copies with slight changes. Using the copy function, you can duplicate an object and modify specific properties. This feature is useful for managing immutable data models, allowing you to update values without altering the original object. Data class copying streamlines data manipulation and supports functional programming patterns. Kotlin's collections processing APIs, such as map, filter, and fold, enable you to manipulate lists and other collections efficiently. These functions allow you to transform, filter, and aggregate data with concise syntax. By leveraging these tools, you can write powerful data processing pipelines that are both readable and maintainable. Lambda expressions are a core part of Kotlin's functional programming capabilities. They allow you to define anonymous functions and pass them as arguments to other functions. Lambdas make your code more expressive and enable flexible data processing. By using lambda expressions, you can build powerful pipelines and handle complex logic with ease. In Kotlin, functions are first-class citizens. This means you can assign functions to variables, pass them as arguments, and return them from other functions. This capability opens up new possibilities for code reuse and abstraction, making your programs more modular and adaptable. First-class functions are a hallmark of modern programming languages. High-order functions are functions that take other functions as parameters or return them as results. Kotlin's support for high-order functions enables advanced programming patterns such as callbacks and functional pipelines. By using high-order functions, you can build flexible and reusable code structures that adapt to different scenarios. Kotlin's Collections API includes tools like map, filter, and fold, which allow you to process lists and other collections efficiently. These functions enable you to transform, filter, and aggregate data with minimal code. By mastering these tools, you can handle complex data processing tasks with ease and clarity. Kotlin's features make it the preferred language for Android app development. Its concise syntax, null safety, and interoperability with Java help developers build robust, efficient apps. Google's endorsement of Kotlin has accelerated its adoption, making it a must-learn language for anyone interested in mobile development. By mastering Kotlin, you unlock new possibilities for creating innovative Android applications. One of Kotlin's greatest strengths is its full interoperability with Java. You can call Java code from Kotlin and vice versa within the same project. This seamless integration allows you to leverage existing Java libraries and frameworks while enjoying Kotlin's modern features. Interoperability ensures a smooth transition for developers moving from Java to Kotlin. Kotlin's concise syntax reduces boilerplate code, allowing you to write less and achieve more. Features like automatic getters-setters, single-line class declarations, and extension functions streamline your codebase. By minimizing repetitive tasks, Kotlin helps you focus on building features and solving problems, making development faster and more enjoyable. Kotlin's null safety system is a game-changer for developers. By distinguishing between nullable and non-nullable types and providing operators like and Kotlin prevents common runtime errors, this system ensures your code is safer and more reliable, reducing the risk of crashes and improving user experience. Null safety is a cornerstone of Kotlin's design philosophy. Kotlin's syntax is designed for clarity and brevity, Features like type inference, smart casts, and string interpolation make your code easier to read and write. By eliminating unnecessary complexity, Kotlin helps you build applications quickly and efficiently. Concise syntax is one of the reasons developers love Kotlin. Kotlin embodies a modern approach to programming, combining safety, flexibility, and expressiveness. Its features are designed to address common pain points in software development, such as null pointer errors and boilerplate code. By adopting Kotlin, you gain access to a language that supports both object-oriented and functional programming, making it suitable for a wide range of applications. Summary: Kotlin offers a powerful set of features that make it an ideal language for modern development. Its null safety system, concise syntax, interoperability with Java, and support for functional programming set it apart from traditional languages. By mastering Kotlin, you can build robust, efficient, and maintainable applications. Whether you're developing for Android or other platforms, Kotlin equips you with the tools needed for success. Now that you've learned the fundamentals of Kotlin, it's time to apply these concepts in real-world projects. Explore advanced features, build Android apps, and experiment with functional programming. Kotlin's modern design and robust toolset will help you tackle challenges and innovate in your coding journey. Continue learning, practicing, and building with Kotlin to unlock its full potential.